Hello students. As we know that each chapter that we study has its own scope and importance. It also allows us to explore new concepts, methods, and various applications in our day-to-day life. This also allows us to know about various career options that we can go ahead with. Metallurgical sciences is one such subject which can be taken under study. You might have also come across fields like metallurgical engineering. We have IIT Roorkee, Madras, and few other institutes providing this course, which allows great future in the study of extraction of elements, judging the right method, technology to check the economical viability in the extraction and isolation of the elements. This picture and the earlier picture is a common scene in Bicholi Taluka. Many of you must have come across this. Goa has a rich source of iron ore. We can see machineries involved in excavating and carrying the truckload of mines. This picture shows dump of ore ready to carry through waterway in the barges. We can also see some screeners put across to obtain fine powder of the ore. With this, let us see some processes which are involved in the extraction and isolation of the elements in our chapter General Principles and Processes of Extraction and Isolation of Elements. Let us know about some common terms we come across as we are studying this chapter. The elements may be found in its native or combined form in the earth crust in form of minerals. Minerals are naturally occurring chemical substances in the earth's crust obtainable by mining. Know that there can be various minerals of a element. That is, a element can be combined with oxygen, sulfur, nitrogen, halides, or any other elements, and it can be obtained in various forms. But only few among these can be used for extraction. This depends on abundance of the mineral, percentage of a element which can be obtained from it, ease of a process involved, cause all this has to make the element cost effective. These few minerals used for extraction of an element is called ore. Let me make it clear that all ores are minerals, but all minerals are not ores. We also see some impurities with the ore, and that's called as gangue. In the picture, we can observe a piece of a ore with impurity or gangue. We design a scientific or a technological process to isolate the metal from its ore, and that is called as metallurgy. The entire scientific and technological process used for isolation of a metal from its ore is known as metallurgy. There are three basic steps involved in isolation and purification of metals. 1. Concentration of ore. 2. Isolation of a metal from its concentrated ore. 3. Purification of metals. Now, as we begin with the three steps which are involved in extraction and isolation of the elements, let us know about the occurrence of different types of element in the earth crust. Because we are taking up with the extraction and isolation methods involved with some of the metals. Let me tell you about the third most abundant element in the earth crust, and that is aluminium. The fourth most abundant element in the earth crust is iron. Can you tell me which will be the second and the first most abundant element? Yes, you are right. The first most abundant element is oxygen and the second is silicon, followed by aluminium and then iron. After this, we have calcium, sodium, magnesium, potassium, titanium, and the list goes on. In this particular chapter, we are more interested in taking up with extraction and isolation of elements like aluminium, iron, copper, and zinc. Aluminium is a major component of many igneous minerals, including mica and clays. Many gemstones are impure forms of aluminium oxide, and the impurities range from chromium in the ruby to cobalt in sapphire. We can see some of this gemstone in the picture given here. Let us see some principal ores of important metals. First on the list is aluminium. In the picture, we see two ores of aluminium. First is bauxite with the formula AlOx OH 3 2x. X, it can be is more than 0 and less than 1. It's a non-stoichiometric compound. At the same time, in the other picture, we see the second ore of aluminium, and that is gadolinite, which is a form of a clay with the formula Al2OH4 Si2O5. This picture shows four ores of iron. First on the list is hematite, formula Fe2O3. Second is magnetite with the formula Fe3O4. These two iron ores are found in Goa. Third in this picture is siderite with the formula FeCO3, and the fourth one is iron pyrite with the formula FeS2. Because of its shiny appearance, golden shiny appearance, many a times it's also referred as fool's gold. Among many ores of copper, four ores have been shown in this picture. The first one with a golden appearance is copper pyrite, formula CuFeS2. The second one is malachite, formula CuCO3 dot CuOH twice. The third one with a silvery luster is cuprite, and it has a formula Cu2O. And the fourth one is a sulfide ore of copper with a formula Cu2S, and it's called as copper glans. Let us also study about some ores of zinc. We have shown three ores of zinc in this picture. The first one is zinc blende, which is also called as sphalerite, and it has a formula ZnS. It's a sulfide ore of zinc. The second one is calamine. This has a formula ZnCO3. It's a carbonate ore of zinc. And the third picture below is zincite with the formula ZnO. It's an oxide ore of zinc.